Hello Chem students, today we're going to learn and review some of the skill that will be on the second part of the test on Friday. Once again, the test will be on Friday, February 4th for the second part, which include mostly on empirical and molecular formula equation. So let's review a little bit. Empirical formula are just the most basic formula of a category of substance. So pretend we're talking about sugar or carbohydrates. Pretty much all sugar or carbohydrates fall to a basic set of a couple different formula. But when they chain together into a molecule that's very, very long, they can have huge molecule. But think of it like pieces of Lego is the empirical formula. If you add them together, you end up with bigger molecule or complex carbohydrates. So once again, it is the lowest possible ratio of a category of substance. So here's the procedure again, just like we did in class multiple times. And I'm just going to do one more example so that way you have a video to use. So we have a sample of acid here containing 0.171 gram of hydrogen. We also have 2.822 gram of sulfur. And we have some oxygen, that's 5.673 gram. And the procedure tells us to convert all of these masses, if it's not given in gram, to mole. And once again, if it's given in percent, just change it to gram for the symbol. So gram goes in the bottom, each one of these, because we started out with gram. Every bracket needs mole one time, and the number in front of mole will be 1. And now we just have to find the molar mass of each one of these substances. So I go to my periodic table, and I'm typing in the periodic table. And I get H to be roughly around, 1.01 gram. Sulfur is around 32.065. And oxygen is roughly about 16 gram. Once again, it's not that big of a deal. It's off by a little bit because we're going to round it off later anyway. So now I grab my calculator and punch it out. So I turn on my calculator and I go 0.171 divided by 1.01 and I get 0.1693 mole. I have 2.822 divided by 32.065 and I get roughly 0.0880. And then this one I have 5.673 divided by 16 and I get roughly 0.35456. So let's just make it 6 mole. And the next step, it tells you to look at all the answer and divide all of them by the smallest one. In this case, and whenever a number divided by itself, you always get 1. So the smallest number of atom in the formula is 1, and that's why we do that step. And just repeat the same thing again for the rest of them. So this, I'm going to punch it out. Divided by 0.088. This one I get roughly about 4.029, so 4.03, and 0.03 is not close to any decimal, so we know that's going to be 4. And then 0.1693 divided by 0.088, that one roughly comes out to 1.923, round it to 4, and that 0.924 is not close to any common fraction, so we know that's going to be close to 2. So that will lead to 2. That will lead to 1, obviously, and that will lead to 4. So the formula will be H2S, because S is 1, and then O is 4. So this is sulfuric acid, H2SO4. So once again, that's all the step to doing empirical formula. Now, once again, if any of this number were to be rounded to, like, say, 5, then you would have to multiply everything by 2, okay? So if any of them end up being 0.5, I'm sorry, not 5, but 0.5, you would have to multiply everything by 2. But in this case, it's a 2, so we leave it as it is. So you would get a couple of those on the test, worth anywhere between 6 to 8 points each, depending on the level of complication it does. Next, we have the procedure for doing molecular formula. So the molecular formula is the real formula of a chemical, and it's going to be a multiple, a whole number multiplication of the empirical formula. So just read through that yourself. But once again, you find the mass of the empirical formula. You have the mass of the molecular formula, which is usually given to you by the machine analyzing the sample. You always take the bigger number divided by the mass of the empirical formula, which is a smaller number. It'll give you a whole number like a 3, a 6, a 5, or whatever. And then you're going to take the empirical formula and multiply it by the multiple to get the real formula. So let's do a couple examples of molecular formula. So here I have the empirical formula is CH2. That means there's 1 C plus 2 H. So that's roughly equal 12 plus 2 times 1, which is 2. So that'll give me a molar mass of about 14 grams per mole for the empirical formula. As I said, take the bigger number for the next step, which is 42.10 grams per mole, divided by the mass that we got. And in this case, 42 divided by 14 is going to be what? And it should always be a whole number. If you get a decimal, you're probably doing it upside down. So in this case, it's going to be a nice 3 roughly, okay? So the real formula will be 3 times the basic formula. So I take the whole number that is calculated and then multiply it by the empirical or the basic formula that we have. So the final answer will be C3H6 in this case. Let's do one that's a little bit more complicated. Once again, just follow the procedure. I have to find the mass of NH2O. That leads to 1 N, which is 14. H will be 1, so 2 times 1 is 2. And then O is roughly 16 grams. So if I were to estimate that roughly, I would get roughly about 32 grams per mole. So now find the multiple. Always take the bigger number given, divided by the calculated number that you have here for the empirical formula mass. And if I do the calculation, I would get roughly how much. And in my case, it's going to be a nice 5, or very, very close to 5. So the real formula, or the molecular formula, is going to be 5 times the empirical formula. So if you have an answer, it will be N5H10O5. Okay. With that, now you should be able to do everything in the homework packet. And if you have any questions, just wait until Tuesday when I come back. Have a good day.